So this is the third video covering Activity 1.1. The first two videos, we really dealt with qualitative graphs. And in this video, we are going to discuss quantitative graphs. So what's the difference? See, qualitative graphs, all of the graphs that we looked at, there were no numbers on the axis, right? It just says speed, right? It doesn't really quantify how fast, or time. It doesn't quantify how many minutes, right? None of these graphs have numbers. So they're qualitative graphs. For quantitative graphs, we can quantify things. Rainfall, how much rainfall fell. Time, how many minutes went by, right? So we look at example 3, and it says the story of a rain shower. All right, so it looks like the first 5 minutes, we have a ½ inch of rain that has fallen. And then the second 5 minutes, it looks like, notice how the curve is steeper. So the steeper the curve, the greater the rate. So the rate of rainfall for the first 5 minutes is not as great as the rate of rainfall for the second 5 minutes. Right here, you can see in the next 5 minutes, we have, it looks like an inch of rain fell. So the first 5 minutes, a ½ of an inch of rain has fallen. The second 5 minutes, it looks like we have 1 inch of rain that's fallen. Because we're really going from here, that distance. And then the next, it looks like 5-10 minutes, the rainfall in inches does not increase, it does not decrease, so that means it stops raining around the 10-minute mark. And I think that's what this story tells us, right? ½ of an inch of rain falls the first 5 minutes, the next 5 minutes, 1 inch of rain fell, for a total of 1.5 inches. And then for the next 10 minutes, the total rainfall stays constant, right? That means no new rain has added, so the rain has stopped at the 10-minute mark. Problem 3. So in problem 3, we're asked to, I guess, match the story to the graph, right? So if you think about it, we're taking a bike ride, and the distance from home depends on the time. So time is t, it's on the horizontal axis, and the distance from home, d, is on the vertical axis. So let's start with letter A. It says I start 5 miles from home, and I ride 5 miles per hour away from home. So if you look at graphs 3, notice here we start 10 miles from home, so that's not good, because letter A says we start 5 miles from home. Graph number 4, also no good, because we start 10 miles from home when it says we need to start 5 miles from home. So when I look at graphs 1 and 2, both of these start 5 miles from home. So now if I'm 5 miles from home initially, and I'm driving or traveling at 5 miles per hour, after 1 hour, I should be 10 miles from home. So if I look at graph 1, right after 1 hour, it looks like I'm 15 miles from home. But in graph 2, after 1 hour, I'm 10 miles from home. So this should be letter A. Okay, and that's really the exercise we have to carry out through B, C, D, and E. So let me just clean up my graphs. Okay, so for letter B, again, we start 5 miles from home. So if I look at graph 1, I'm starting 5 miles from home. And if I'm traveling 10 miles per hour away from home, well, after 1 hour, I should be 15 miles from home. Right? Because I start 5 miles originally. 1 hour later, I travel 10 miles. So I should be a total of 15 miles from home. So graph 1 is letter B. Again, let me clean up my graphs. Okay, let's look at letter C. Now I start 10 miles from home. Okay, so graphs 1 and 2, remember, these both were 5 miles from home, so we can exclude them. So now if we start 10 miles from home, okay, that's 10 miles from home, that's 10 miles from home. And 1 hour later, I'm home. So that means after 1 hour, my distance from home should be 0. So notice this one, it takes 2 hours for me to get home, where graph 4, I'm home in 1 hour, right? Because my distance from home would be 0 if I'm at this point. So letter C would be graph 4. And again, I'm going to clean up my graphs and we're going to work on letter D. Okay, so graph D, again, we start 10 miles from home, so that's got to be either graph 3 or 4. And I'm halfway home after 1 hour. So if I'm 10 miles from home originally, after 1 hour, or I should be halfway home, that means I should be 5 miles from home after 1 hour. So if I look at 1 hour, 5 miles from home, right? That's half of my initial distance. Right? My initial distance was 10. After 1 hour, I'm halfway home, which would be the 5. So this is letter D. And let me just clean up the graphs again. All right, last but not least, letter E. We start 5 miles from home, so I know it's either graph 1 or graph 2. Oops, my drawing went off. There we go. 5 miles from home. And I'm 10 miles from home after 1 hour. So after 1 hour, if I look at this graph, I'm 15 miles from home. That's too much. Graph 2, after 1 hour, I'm 10 miles from home. So that's okay. So this is also letter E. So graph 2 corresponds to letter A and letter E. Okay? And this is a great exercise. This is definitely, I love graph matching type problems for quizzes and tests. So make sure you're comfortable with this. All right, let's scroll down to letter D, separate problem. What is the story for this graph? Well, here it looks like my distance from home is not increasing, it's not decreasing. So as time gets larger or time goes by, my distance from home doesn't change. So it looks like I'm 10 miles from home and I'm basically stopped. Maybe I'm in a library or I'm in the mall 10 miles from home, or maybe I sit in the classroom at Brookdale, which is 10 miles from home for 2 hours. So I'll write some make-believe story here on the right. I added my name. I just said, Mike is at rest 10 miles from home. And I think that's good enough. If you're a creative writing major, maybe you want to spruce this story up. On a cool summer day, Mike sits in the blissful cafeteria at the Brookdale dining hall 10 miles from home. That's fine. But I don't have a creative writing background, so I'll just simply write, Mike is at rest 10 miles from home for at least these 2 hours. I think that should do it for this video, and we'll finish up this packet in the next video or two.